We'll see how to count number of triangles from the figures. For that, let us recap the basic shapes and the number of triangles associated with them that we have seen in the previous videos. Check the description for the link of those videos. So these two are the basic shapes we will use to count the number of triangles. In this square, this particular pattern will give 8 triangles and this pattern will give 3 triangles. Now in this figure we have two square patterns. So each makes 8 triangles. So 2 into 8, that is 16 here. And then we have 4 more triangles here, 1, 2, 3 and 4. We'll add these 4 to 16. Now consider this upper part. This is again like a triangle pattern. So this particular thing is like a triangle and then we have a middle vertical line. So this pattern would make 3 triangles. So this is 3 and even the lower part is like a triangle pattern. So that part also will make 3. 3 from upper pattern and from the lower pattern as well. So 2 into 3. So this gives 6 triangles more. And we also have 1 and 2 more triangles like this. So we'll add those 2 triangles as well. Add these things and we'll get 28. This figure has got 28 triangles. Now consider this pattern. Here we have 2 squares, one here in the upper part and the second one in the lower part. So for these two, we can write 2 into 8, 16 triangles. And then we have 1, 2. 2 more triangles here. So we'll add those 2. After that, we have triangle patterns. Triangle pattern 1 is here. So this gives 3. Similarly, we have one more triangle pattern here. So this also will give 3 triangles. So 3 plus 3 is 6. Along with this, we have 1, 2, 3, 4 triangles. So we'll add these 4 also. Add these together and this gives 28 triangles. Consider this particular figure. This is a triangle. If we have a triangle like this and another triangle embedded within this particular triangle, in this case, to count, we can directly see the triangles here. There are 4 triangles. Along with that, there will be another bigger triangle. So in total, we have 5 triangles. This same can be obtained using another formula, that is 4n plus 1, where n stands for the number of triangles embedded in the outermost triangle. Here we have only one triangle, so we can say 4 into 1 plus 1, that is 5. In this figure, we have 1, 2 triangles embedded. So in the formula, we will substitute in place of n 2. That is 4 into 2 plus 1 equal to 9. So this figure will have 9 triangles. Let us take another example. Here we can see that now 1, 2 and 3. 3 triangles are there. We'll be using the same formula. Substitute 3 in place of n and we'll get 13 triangles. Like this, there can be any number of triangles embedded within. We'll try to solve another problem. Here we have the lines extra in this figure. If we don't consider those lines and count the triangles first, the figure would look like this. This is same as the previous pattern and we have got 2 triangles embedded here. So from 4n plus 1, if we substitute 2 in place of n, we'll get 9. Now consider the lines. Because of those lines, the upper triangle has got divided into 2 parts. Similarly, here 2 and again here also we have 2. So we have 3 such things. So plus 3 into 2. This gives 9 plus 6, that is 15 triangles in this particular figure. Now consider this figure. If we have to calculate the total number of triangles, see this is like the previous pattern. Because of that, we can say this will make 5 triangles as we have only one triangle embedded here. After that, here we can see we have 1, 2, 3, 4, 5 more smaller triangles. So 5 from the pattern and 5 smaller triangles. And apart from that, we'll have 1, 2, 3 triangles. So we'll add these 3, that gives 13 triangles in total. Instead of like this, we can use 2 more ways of calculating triangles for this particular pattern. Now check this. When we have like this, first we have to count the number of triangles with this horizontal line as base. So we have 3 triangles. In similar ways, for each and every side of the bigger triangle, we have 3 triangles. So like this, if we have same number of triangles here for all the sides, we can use a formula, that is n into n plus 2 into 2n plus 1 divided by 8, where n stands for the number of triangles with that particular side as base. Here we have 3. When we substitute 3 in place of n, we will get this particular substitution. Now when we simplify this further like this, here we have 13.1 and so on. When we get like this, we have to ignore the decimal part and consider the whole number part only. So 13. In this particular figure, we'll have 13 triangles, which is same as the count we have obtained in the previous step. If remembering this particular formula is also difficult, then what we can do is, we have written 1, 2, 3 like this. Now write these numbers in this manner, 1, 2, 3. We'll write 1 as it is, then add this 1 to 2 and write the result here. Again add the 3 to 3 and write the result here, 6. Now we have to add all these numbers. 1 plus 3 plus 6 is 10. From bottom onwards, we have to add every alternate number. Here, leave the 6 and then add 3. So 10 plus 3 is 13. This is same as what we have seen just now. Consider this particular pattern. Here, if we see, we have 1, 2, 3, 4 triangles as base. Now when we substitute this in the formula, we'll calculate how many triangles we can get here, where n equal to 4, because here we have got 4. 4 into 6 into 9 by 8. Now on simplifying this, we'll get 27 as the value. Again, we can check the second method of doing this as well. Write down 1, 2, 3, 4. Write 1 as it is. Add this to 2 and write the value. Add this to 3. 6. 6 to 4. That gives 10. Now add all these values. 1 plus 3 plus 6 plus 10. That gives 20. After that, from bottom, we have to consider alternate numbers. Then we'll get 6 and 1. 6 plus 1 is 7. Adding that to 20, this gives 27. So here 27, and even in this first method also we got 27. Let us check with one more example. Here we have more triangles. Now on base, we have got 6 triangles in total. So the formula is n. N means 6 here. 6 into n plus 2. 6 plus 2 is 8 into 2n plus 1. 2 into 6, 12 plus 1, 13 divided by 8. Now if we see here, this is 78. This is the method using formula. In case we can't remember the formula, we can directly write the values like this and do the process here. This 6. 6 plus 4 is 10. 10 plus 5 is 15. And again 15 plus 6 gives 21. Now add all these values. 56. For this we have to add alternate number from the bottom. That is 15 plus 6 plus 1, which is 22. Adding 22 here, this gives 78. So in both the methods, we have got 78 as the answer. This particular pattern. If we observe here, there is a line coming from the vertex to the opposite side. For all the three sides, we have got these lines. To count the number of triangles in this particular figure, first we check here the number of smaller triangles we are able to see. There is 1, 2, 3, 4, 5, 6. These are smaller triangles without any overlap. This 6 plus n square. N square means number of lines that are drawn from the vertex and completely touching the opposite side. Here from all the three vertices, we have the lines touching the opposite line. So we'll write 3. So square of 3 plus 1 for the bigger triangle. Now this becomes 6 plus 9 plus 1. This is nothing but 16. The figure will have 16 triangles. So now look at this picture. To solve the number of triangles in this, we can use the previous method. Here we have smaller triangles 1, 2, 3. This is not a triangle. Use this 3 in place of smaller triangles plus n. N is the line from vertex to opposite side. We have this line and again this line. 2 lines are there. So we'll write 2 square plus 1 is equal to 3 plus 4 plus 1, that is 8 triangles in this figure. Count the smaller triangles here. We have 5 triangles. So 5 plus lines from vertex to the opposite side, only 2 lines. This line and this line were complete and this particular third line is not complete. So we'll consider 2 square plus 1. That is 5 plus 4 plus 1, which is equal to 10. In this particular figure, to count the number of triangles, we have the smaller triangles here 1, 2, 3, 4, 5. These 5 triangles plus we have more triangles like this here 1, 2, 3, 4, 5. So if we add these 5 triangles as well, we get 5 plus 5, 10 as the total number of triangles. Consider another pattern. Say in this, to count the number of triangles, we have these smaller triangles here, 6 smaller triangles plus 1 and 2 big triangles also we have. In total in this pattern we'll have 8 triangles.